slider. First, we set the crank angle indicator and linear scale as instructed. To the linear scale reach 0 when the slider is furthest right position and the crank angle shows 180 degree. Next, turn the crank to 0 degree. Slider should now be at its furthest left position, indicating a displacement of around 30 mm.
As you rotate the crank clockwise in 10 degree step, use the flank result table and note the displacement reading on the linear scale.
Next, we go to second procedure, which is crank force. First, set the crank angle indicator and linear scale as instructed. Add a 500 gram fixed load to the slider. No need to record the slider displacement on the linear scale, so move the red clip away so it does not interfere with the movement as the crank rotates. Allow the slider load to pull the crank around and set the crank angle indicator to 0.
Okay, next is set the spring balance to 0. Then wrap the cord around the crank at least once and then up to the spring balance. Right. Then while gently tapping the panel to reduce friction, carefully slide the spring balance upwards to pull the crank around in 10 degrees intervals as far as you can before the crank overhauls and pulls itself around. You should be able to get at least 130 degrees. Then at each step, record the force on the spring balance.
For the result, the spring balance upward to pull the crank around in 10 degrees. 10 degrees.
Right.
10 degrees, 10 degrees. Okay. So we can see the result is at 0.2 cm. Repeat the experiment by adding 10 degrees each procedure. So 20 degrees